going live in the live stream. And I'm live. Wonderful for me. Great. So just as a heads up, in regards to your majors, yesterday I tried to, as quickly as possible, post all the comments. All week, I've been grading your majors, and I've been keeping the comments aside in a spreadsheet that I've been organizing for the grades. And then when I wanted to submit the grades, I wanted to put the comments in as well. So I tried to do that as quickly as humanly possible. If you have any specific questions in regards to the major that you took or the grade that you got in the comments that were put there, please make sure you are emailing me separately, and we can kind of have that conversation from there. And we'll go from there. It'd be great. But that was chapters 10, 11, and 12. That was unit 3 in AP Statistics. Now, obviously, a lot of that information is going to come back around for you in regards to future things that we tend to go over. Oh, look, I got 9 people live right now. Everyone give me a thumbs up. I just want to see, not a thumbs up for there. I want to see a thumbs up in the chat. I want to see who's here. So you guys do that while I kind of walk around. But anyway, but that stuff will come back around. Yes, oh yes, oh yes, it will. We will continue to review that information. Now, in regards to the 5-day-a-week thing, no one really explained this to me. When we go back 5 days in November, are they going to go back to the AB schedule? You know what I'm talking about, right? No one said anything. All right, am I going to see you like 2 or 3 days a week? I would prefer that. Second? Yeah, that's what I'm kind of hoping. Because if we do, then we can actually get back on a regular schedule. I have tried my best to keep you on pace with my previous year's AP Statistics courses. Right now, what is today? The 15th? Right now, we are currently a week and a half behind. Just a week and a half behind because I'm only able to see you guys once a week. But once we switch to 5 days a week, then I'll actually be able to get back on a regular schedule and get you moving. It's so great. Oh, what do you got? I got people don't know how to do the emoji for thumbs up, so they literally type the word thumbs up. So, good. Dude, I have no idea. See, the thing is, it's like I just kind of show up and do my thing. All the stuff that I teach you is completely made up, and no one ever stops me. I just kind of show up and do my thing when they tell me to. You're going to find out by the end of the year, you're like, oh, crap, he taught us fake stuff. Anyway, back to this. So we are jumping to the beginning of the textbook. Now, if you happen to read chapter 1 in the textbook, that was just kind of an aside. That was an intro to everything that we're all about here. But the chapters that we're really focusing on today and part of next week as well are going to be chapters 2 and 3. I did say 2 and 3, right? I didn't say 3 and 4? Okay, just making sure, because when we switched over to the new version of the textbook, they did switch over the chapter titles, which I was a little like, but that's okay. But yeah, chapters 2 and 3 are all about graphical displays. Now, in the past month or so, you guys have put together survey or topics and eventually survey questions for me. They are going to come back around eventually. I'm going to leave them alone for a little bit. But we need to learn about graphical displays, because once we actually go out and, or I can't actually send you out, once we figure out how we're going to collect the data, we'll have that conversation when the time is appropriate. But once we figure out how to collect the data, we need to know how to display said data. You guys know about certain displays. I think you know about scatter plots, correct? Heard of them. You guys know bar charts and pie charts and stuff like that, right? Do you know anything else beyond that? Any type of graphical display besides the 3 that I just mentioned? Oh, crap. Okay. What's a histogram? Question. What's the difference between a bar graph and a histogram? Huge difference, though. There's a huge difference between the two, and we'll get into those details today. First, I got 16 people. Look at that. That's great. Crazy people. You should all tune in for my actual channel so I make money off of that one. Anyway, back to this. I'm going to start with a video. Now, I'm going to put this the microphone next to the speaker, so hopefully you can hear what's going on, you people in the chat. But this is just an introduction to something. Now, the 20-minute video that I set aside for you, that is like a long TED Talk. This is a short TED Talk. This is called the TED Ed. I don't know if any of you are subscribed to the channel for TED Ed. It's fantastic. Just saying, subscribe to good stuff on YouTube, not the garbage stuff. But this is a quick 4-minute video talking about misleading graphs. Give you an opportunity to watch this. Here we go. Who? No, different guy. Yeah.
A toothpaste brand claims their product will destroy more plaque than any product ever made. A politician tells you their plan will create the most jobs. We're so used to hearing these kinds of exaggerations in advertising and politics that we might not even bat an eye. But what about when the claim is accompanied by a graph? After all, a graph isn't an opinion. It represents cold, hard numbers, and who can argue with those? Yet, as it turns out, there are plenty of ways graphs can mislead and outright manipulate. Here are some things to look out for. In this 1992 ad, Chevy claimed to make the most reliable trucks in America using this graph. Not only does it show that 98% of all Chevy trucks sold in the last 10 years are still on the road, but it looks like they're twice as dependable as Toyota trucks. That is, until you take a closer look at the numbers on the left and see that the figure for Toyota is about 96.5%. The scale only goes between 95 and 100%. If it went from 0 to 100, it would look like this. This is one of the most common ways graphs misrepresent data, by distorting the scale. Zooming in on a small portion of the y-axis exaggerates a barely detectable difference between the things being compared. And it's especially misleading with bar graphs, since we assume the difference in the size of the bars is proportional to the values. But the scale can also be distorted along the x-axis, usually in line graphs showing something changing over time. This chart showing the rise in American unemployment from 2008 to 2010 manipulates the x-axis in two ways. First of all, the scale is inconsistent, compressing the 15th-month span after March 2009 to look shorter than the preceding 6 months. Using more consistent data points gives a different picture, with job losses tapering off by the end of 2009. And if you wonder why they were increasing in the first place, the timeline starts immediately after the US's biggest financial collapse since the Great Depression. These techniques are known as cherry picking. A time range can be carefully chosen to exclude the impact of a major event right outside it. And picking specific data points can hide important changes in between. Even when there's nothing wrong with the graph itself, leaving out relevant data can give a misleading impression. This chart of how many people watch the Super Bowl each year makes it look like the event's popularity is exploding. But it's not accounting for population growth. The ratings have actually held steady, because while the number of football fans has increased, their share of overall viewership has not. Finally, a graph can't tell you much if you don't know the full significance of what's being presented. Both of the following graphs use the same ocean temperature data from the National Centers for Environmental Information. So why do they seem to give opposite impressions? The first graph plots the average annual ocean temperature from 1880 to 2016, making the change look insignificant. But in fact, a rise of even half a degree Celsius can cause massive ecological disruption. This is why the second graph, which shows the average temperature variation each year, is far more significant. When they're used well, graphs can help us intuitively grasp complex data. But as visual software has enabled more usage of graphs throughout all media, it's also made them easier to use in a careless or dishonest way. So the next time you see a graph, don't be swayed by the lines and curves. Look at the labels, the numbers, the scale, and the context, and ask what story the picture is trying to tell.
Now, what story the picture is trying to tell is an interesting question unto itself. What story is the picture trying to tell? So, for example, this picture right here. Now, you look at this, you say, okay, the top's tax rate if the Bush tax cuts expire. This is a graphic from about 8 years ago or so. What story is this graph trying to tell? Well, if the tax cuts expire, then your taxes are going to skyrocket. It looks like at first glance that this thing is going to go up by 1, 2, 3, 4 times as much, according to the scale. Now, clearly it's not. The numbers are not lying. The numbers are telling you the exact truth. Now, whenever the day was that this was published, and January 1st, 2013, it's 35% up to 39.6%. They didn't say that the taxes would expire. They didn't tell you that everything would be blowing up and going crazy. The scale is pretty consistent. I mean, obviously it starts at 34. Clearly the taxes are going to go up if this thing is allowed to happen. But the story that they're telling, by the way they decide to frame it, is it looks like it's going to explode. It's going to go up 4 times as much, even though in reality it's only going from 35 up to 39.6, something along those lines. There are other examples of graphs that people manipulate. Let's see which one I wanted to go to. By the way, this one right here, this itch relief one, for the life of me, I have looked at this graph for the past 5 years. I still cannot figure out what it's trying to tell me. I can't. I don't know what to do. Literally, it's an advertisement like a magazine. It's a clinical preference study of itch relief. Okay, there's a study. Cool. And then Lanacane, 1 minute versus 60 minutes. I don't get it. I don't understand what it's trying to tell me, but it's doing its thing. So I'm just going to say, okay, I guess if I ever need itch relief, I'll just scratch it. Anyway, this one was pretty funny. This graph is technically not lying to you if you know what it is you're looking at. In 2012, before the Republican candidate was chosen, the Republican candidate ended up being Mitt Romney. There were 3 major candidates back at the beginning of the primary season. This is probably late 2011 they posted this, whatever. But it was Sarah Palin, Mike Huckabee, and Mitt Romney. And somebody put this pie chart together. And clearly this pie chart is ridiculous. Because if you have a pie chart, what should the percentages all add up to? 100%. Clearly this one doesn't. But the thing is, this data is not just made up. And it's not like somebody made a mistake with the numbers. They did not make a mistake with the numbers. See, in reality, what ended up happening was this was favorability ratings. It was basically like they went to a bunch of prospective Republican voters and they asked them, what is your view of Sarah Palin, good or bad? And then if they said good, then they counted you in the favorable category as opposed to the unfavorable category. So of 100 people, Republican voters, 70 of them said that they would, I think Sarah Palin's pretty good. 60 said Romney's pretty good. 63 said Mike Huckabee's really good. But this is not the graph to choose. See, the numbers are correct, but the graph is wrong. What they really should have done is probably a bar chart. And then that would be okay, here are the favorability ratings. But no, somebody who, doesn't really understand numbers or thought that a pie chart looked prettier decided to do something like that. I thought there were more on here, regardless. See, the thing is, when it comes to graphical displays, people tend to stick with what they know, I guess, or stick with what they're kind of familiar with. They tend to try to show data in such a way where it's listen, look, I have a graph and it looks nice and it looks pretty or whatever, but they really don't know what they're looking at. I mentioned the 20-minute video. Now, obviously, I'm not going to show you the 20-minute video today. You watch that on your own time. But what that guy is doing in that 20-minute video is he's trying to show you that graphs don't just have to be plain scatter plots or histograms or bar charts or stem and leaf plots or box and whisker plots or things of that nature. They could be something a bit more dynamic. In one instance of a chart, he's showing, I think on the x-axis, there's fertility rate, and on the y-axis, I can't remember exactly what it was. I wanted to say medium household income or something along those lines. And then each bubble represented a country, and then the size of the bubble represented the population. And then he showed the movement of these bubbles on this chart over the course of time from 1960 to 2003. It was amazing. Standing ovations for him. Go watch that video when you get the chance. It's fantastic. Obviously, you're going to have to. It's part of your assignment. But for now, ladies and gentlemen, I need to get you some information. I need to get you some things that you may or may not know how to do. But I'm going to ask you to do two things. Number one, I am going to ask for those notebooks to be out and open. But also, more importantly, I'm going to need those Chromebooks out and open. I'm going to need you to open up the Graphing Calculator app because I need to show you how to use something. Several things. These calculators can do a lot more than you think they can. Some of you know that. Most of you don't. When I was in high school, I got super bored in trigonometry class. So me and my friend Sam, we sat down with a graphing calculator and took 2 weeks to program in our version of tic-tac-toe into the graphing calculator so we could play it during class. It was phenomenal. Trigonometry was too easy, so I figured I'd take on a challenge. This one works. Go away, marker. Ah! Let's just say I made it in. See? No. Made it in. There you go. All right. Let's call this graphical displays. Now, this is going to be over the course of multiple lessons. Please keep that in mind. This is covering chapters 2 and 3. I am going to be jumping back and forth between chapters 2 and 3. I'm not going to be keeping them separated from one another. Please keep that in mind. And today is the 15th. Now, what's really interesting, you guys have the graphing calculators on your computers, which is fantastic. Good for you. Oh, happy day. When you open them, please correct me if I'm wrong. They say RAM cleared. Good. If you have that, then there's no harm, no foul. Everything's cleared. But keep in mind, I am going to show you how to input data into your graphing calculator in a little bit. I have something set up for that. But if you close your calculator and then open it again, anything that you've entered into the calculator will automatically be deleted. So please be careful. If you enter in a bunch of data and then close it out, open, oh crap, it's all gone. Don't do that. Don't be that person. Anyway, I'm trying to open the chat right here so I can see it while I'm writing. So anyway, first and foremost, if you did have a physical calculator, just as a side note, some of you already know how to do this. But if you did have a physical calculator, you could reset that thing by typing out second plus sign 712. Now, please correct me if I'm wrong. Your second button on the computers, are they blue? Cool. Mine's yellow. Obviously, that's what people are typically used to. If you have TI-84 or whatever it is you have, then yeah, typically the second button ends up being blue. But just to point out, as you all may or may not know, when you hit that second button, you're going after the command that's typically written in yellow for me, and it would be written in blue for you. You also have an alpha button, which I'm sure you guys have had a lot of fun with, typing short messages to your friends and then quickly deleting them. I don't know. No? Okay, fine. But you can see on my calculator, if I hit second and then plus sign, and then you can see number 7 is reset, and then 1, all RAM, and then 2 is reset. That just resets the calculator. You don't have to worry about that unless you had a physical calculator. Oh, happy day. In a moment, this is the more important aspect. I want to show you how to enter your data. Oh, I'm zooming out. I want to show you how to enter your data. Now, to get to the location where you're going to enter your data, you are going to have to hit 2 commands. First of all, stat, and then the button for edit. The stat button is located in the center column, third button from the top, STAT. If you hit that button, then the first option that you should get is the word edit. Let me show you here. I'll zoom back into my calculator. Zoom and zoom. If you hit stat, you'll come to this screen right here. You need to get very familiar with what's on here, especially these other tabs as well. You're going to get very familiar with these tabs. But anyway, the first function is edit, and you come here. This is where you typically enter your data. List 1, list 2, list 3. This thing actually goes all the way to list 6, and you could add more as well if you wanted to. If you actually went up to L6 and moved over, you could type in your own numbers as well. But that's besides the point. That's not the purpose of today. The purpose of today is focusing on list 1. If you wanted to enter data, it's just a simple matter of typing in those numbers. Now, let's just pretend I wanted to type in 1, 2, 3, 4. Let's just say I wanted to type in 1, 2, 3, 4. All right, 1, enter, 2, enter, 3, enter, 4, enter. Good job, me. Good thing I didn't make any mistakes. Oh, no. I wanted to type in 1, 2, 3, 4, and I ended up typing 1, 2, 6, 4. What must I do? Well, you don't actually have to clear it. You could just overwrite it. Where literally, if you go back to the 6 and just type in a 3 and hit enter, boom, it's changed. Now, let's just pretend for just a moment that I didn't want to type in 1, 2, 3, 4. Let's pretend that I just wanted to type in 1, 3, 4. 1, 3, 4. Oh, no. I just wanted to type in 1, 3, 4. How do I get rid of it? If I hit clear, it does that. If I hit enter, nothing happens. The clear button doesn't do it. You got to understand where you're at on this calculator. You got to understand the proper commands here. In order to remove a data point from the list, you would actually have to hit the delete button, DEL. You would actually have to hit the delete button on the calculator, not your computer, but on the calculator. DEL obviously is right there at the top next to mode. And if you hit delete, boom, now that data point goes away. Hey, let's say that I did this. Let's say that I had all this data here in list 2 that was perfect, but I wanted to clear out list 1. Instead of having to like delete, this is actually really cool. You can go up to L1 right there. That's where you could hit clear and then press down, and that's where it all goes away. It's phenomenal what this thing can do. You just have to know how to use it. You guys ever seen computers back from the 80s where you had to type in like DOS and all that other stuff? No? Whatever. You ever play a text-based adventure? No, nerds? You have? What do you mean technically?
You ever heard of AI?
No.
It's basically just text-based
Okay.
adventure that you make up.
It's pretty fun though. I like text-based adventures. But back to this. Now, here's what I want you to do. I want you to enter in some data. Chapow. Oh, hold on. Where'd it go? Oh, it's scrolled over. Scroll over more. What are you doing? Page? This thing? Hold on. Page 73. It's off center. Page 73. There we go. Zooming in, zooming in, zooming in, zooming out. I had this whole thing set up and then it fell apart on me. Here are the prices of gasoline in eastern Wisconsin. There's 16 data points. What I want you to do, I want you to type in, and I'll move this so people on the computer can see it. Oh my word. What in the world just happened? There it is. I want you to type in, oh my word. What is going on? Gosh, can they see that? I hope they can see that. Let's hope for the best. I want you to type those in. I'm just trying to resize the screen so they could see it a little bit better. You know what I'm saying? Zoom out just a tiny bit. That's a little better. Kind of. Anyway, that's the one I want you to do. And I'm going to do the same thing as well. Hopefully you guys can see that on the computer. I'm looking at what you're looking at right now. Hopefully that works. I'm going to type that in. I got to do the same. And then we can do that together. 2.19. After you have typed them in, go through it again to make sure that all the numbers are precisely what you need them to be. Now, if you notice, if you're on your last data point, after you typed in whatever the last number you did, I'm going to assume the last number you typed in was what, 2.25 or some junk like that. After you type that in, you're highlighted just below it. You see where it says like L1 parentheses 17? L1 parentheses 17 is blank. That's fine. Leave it blank. But that's the 17th data point. It implies that you've entered 16 data points. Just as a side note, you need to recognize what this thing is. Because if you're entering in like 45 data points, I need you to recognize where you're at with this thing. Okay. I'm going to give people in the chat a few moments to kind of catch up with that. And I guess, I don't know, we're going to create something. You mentioned a histogram earlier. We're going to do a histogram, right? Cool. So, I mean, if you hit graph right now, if you just hit graph on your calculator at this very moment, I mean, did you do it? There you go. Nothing happened, right? Good. Nothing happened. Nothing happened because you still have more work to do. Anyway, back to me. What's this? Cool. So let me go back to this screen. There we go. Zooming back out. There's all my data points. So here's the thing. If you want to see a graph, if you want to create what we want to create, which is a histogram, then you're going to have to go through a few steps. First of all, we need to turn on a plot. We need to turn on a plot. And to turn on a plot, you have to go through the following commands. First of all, second y equals. If you hit second y equals, what function on the calculator does that take you to? What's written above the y equals sign in that little bluish color? Stat plot, that's where you want to go. You want to hit second y equals, and then you want to hit enter. Because if you hit that combination of keys, and I'm going to zoom in on my calculator so you can see me as well. If you hit second y equals, it takes you to this screen, which has all of your plots. What do you notice about all these plots? What do you notice about them? Do they all have something in common? They're all off. This whole thing, you got to turn a plot on. So if I hit enter on the first one, it takes me to this screen. Now, this screen is where you're going to toggle on or off. And clearly, I'm going to toggle this thing on for a moment. But if you notice, there are other things on the screen. There are other things on the screen. If you hit second y equals and then hit enter on plot 1, it takes you to this thing where you can toggle it on, but then you can pick the type of graph that you are going to pick. Now, you're going to get very familiar with this because if we have data that you need to look at the graphical display, you need to be able to do that very quickly. On this screen, it is automatically set to scatter plot. It is automatically set to scatter plot. And if you notice for scatter plot, they do ask for two different variables, an X list and a Y list. Now, that's not what we have. We only entered in data into L1. We'll do scatter plots eventually, I believe, when we get to chapters 6, 7, 8, 9. Yes. But for now, that's not for us. It's a line graph. Now, we're not really going to deal exclusively with line graphs. I'm just going to skip over that one for now. This is a histogram. This is the histogram that you're eventually going to want to use. And that's the histogram that we're going to use for this example. These are two examples of box and whisker plots. I don't know if you've ever seen a box and whisker plot before. Some of you, yeah. Okay, good. This one with the dots deals very particularly with outliers. I'm going to skip that. I'm not really going to worry about outliers in this case. I would deal with this box and whisker plot, which we'll take a look at in a little bit. This last one's a little crazy. This is called a quartile plot. Quartile plots we're going to use in this class eventually when we get to the normal distribution. The quartile plot is actually one of those things determining whether or not your data is normally distributed. But we will get there eventually. For now, my focus for today is going to be either on histogram or this particular box and whisker plot. So what you have to do, you have to toggle down here and hit enter on the histogram. You got to hit enter on the histogram. So I'm going to toggle over myself. Hit enter on the histogram. Now, if you notice when you hit enter on the histogram, Y list went away because a histogram only deals with one variable statistics. And that's all that we're really going to worry about for this thing. So here we go. Wait, what's up? You get to pick a color? Oh, that's awesome. Well, I don't have that option. But everything is set up. Everything is good. We've turned our plot on. We have a histogram there. We could hit graph and you're going to see something. You're going to see something when you hit graph. Let's hit graph. Well, that doesn't. What the heck is that? Don't say bar graph. Histogram. That's not exactly what I wanted, though. I want something a bit nicer. See, because the thing is, we still have to do something else. I know, right? Stop raising those eyebrows. Anyway, back here. Okay, I can do it too. All right. Anyway, whatever. I taught my son how to do that when he was like 2 years old. And basically, he does that to like any older lady and they melt. Anyway, back to this. So after you second Y equals enter, you're going to obviously turn the plot on and you are going to select the type of graph, whichever one is appropriate for that particular situation. Sometimes it may be a histogram. Sometimes it may be something else. Who in the heck knows? But the thing is, we hit graph, and when we hit graph, we saw the bar, but it didn't really help us. See, the thing is, when you look at something like this, it doesn't really give you any helpful visual information. So we're going to have to change the window. So then I ask you the following question. If we have to change the window on the calculator in order to fit this graphical display, if we have to change the window, if only there was something on the calculator that would help us fix the size of the window. No, it's not actually. It's not. It will be zoom. If you hit window, don't do that. Don't go to window and do that, because if you go to window, you're going to have to actually manually edit the minimums and maximums of the X values and the resolution and the scale. Don't do that. Instead, hit zoom. If you hit zoom, the function that you are going to be most interested in is option number 9. And I hope it's the same on yours. I believe it says zoom stat. That's the one that you want. Hit that, and we'll write down some notes in a moment. Yeah, much better, right? Yeah, much better. This is the appropriate histogram that you want. Hit trace. You see where the trace button is next to graph? If you hit trace, you can actually see how many data points are within that particular block of data. For example, between 219, which is the minimum, and 2.24, you have about 4 data points that were in there. I think there's going to be 6 in the next one. If I scroll over to the right, chapow. There we go. There's 6 in there. You can tell by the scale on the side. Then it looks like there would be back to 4 in here, and then 1 in there, and 1 in there. This is an appropriate histogram. What the heck's going on here? There's nothing there. Now, there's nothing there mainly because they wanted to keep the distance between each block consistent. And because they did it in that fashion, there just so happened to be an empty block there. But that's okay. That's perfectly fine. We are prepared and ready for that. So let's go back to our notes very briefly. So if you want to resize the window, I would rather you hit the function for zoom and 9. That is a much better option than actually trying to resize the window yourself. That would be kind of ridiculous. So don't do that stuff. and it gives you the appropriate histogram that we're looking at. Which is nice, just really nice. So now, if we had to describe it, sometimes you're going to be given questions where it says, here's a bunch of data, describe the distribution, or describe the association, or something along those lines. And if you had to, there are certain rules that we go by. There are certain rules that we go by in statistics to describe a distribution like this. I mean, if you had to describe it, maybe you'd mention the gap there. What else would you say about this stuff? Like if you had to, if I said, hey, describe this distribution, what would you tell me? Besides the gap. Interesting. What else? We'll talk. We'll talk. Back in late elementary, middle school, you guys like did all these calculations for like mean, median, mode, and junk like that? You called them like the measures of central tendency? Did you? No? Whatever. Shut up. First of all, mode is dumb. Just saying, it's dumb. You're talking to a stats teacher. Mode is dumb. Second, remember when you calculated range, where it was like maximum minus minimum? Also dumb. Nobody uses range. We use a more specific type of calculation here, which we're going to get to. Here's the thing. Back to our notes. There's a lot of things in stats that are dumb that I don't know why they taught them to you. I don't know why. To describe a distribution of data, they may also say, they may also use the phrase describe the association. I just want you to be prepared for whatever it is that they're asking for. So they might say describe the distribution or describe the association or something along those lines. In order to do that, to describe it properly, you must cuss. You must cuss. Clearly, hopefully, it took you a few moments to realize that I'm talking about an acronym. This acronym is going to help you figure out how to properly describe a distribution. Now, we mentioned the gap. You mentioned that most of the data seemingly was to the left. We're going to do something slightly different in terms of description, but we'll get there in a little bit. So, let's talk about this. The C stands for the center of the data. Now, I mentioned the phrase measures of central tendency. What's the most basic measure of central tendency? What is a statistic that you could calculate that hopefully would try to describe the center of the data? The average, the mean, or the median. There's two main ways to describe the center of the data. You could describe it as the mean or the median. So now the question becomes, which one do we use in this case? So if data is symmetric, and hopefully you recognize what symmetric is, being that you all went through geometry. If the data is symmetric, use X bar or the mean. But what if it's not symmetric? If data is skewed, R, we're skewed. Use the median. If you were to describe the center of the data, if it's symmetric, use X bar. If it's skewed, use median. Now, what does skewed look like? I'm going to draw pictures in a little bit. I'm going to draw pictures when I get to another letter in the word cuss. Let's talk about U. U is unusual features. U is unusual features. Do you have any gaps? Outliers. Multiple peaks. Things along those lines. Do you have anything that's unusual? You're going to have to describe that. Now, you guys know the word outlier, but you may not recognize exactly how to quantify the word outlier. When I say quantify, I mean this. When people are like, well, is it an outlier? And they're like, yeah, it's an outlier. And then I'll say, okay, well, how do you know it's an outlier? And they'll say to me, well, just look at it. And then I laugh at them. I laugh at them long and hard. It's pretty funny when they say, just look at it. Well, just look at it. No. In order to quantify an outlier, there actually is a formula to do that. We'll do that formula a little bit later. We'll do that formula a little bit later. The first S is called shape. Now, the shape, I've just described a few shapes here. It could be a symmetric shape. It could be a skewed shape. It could be uniform. It could be what we call normal, which we're going to get into the details of a normal distribution in a future chapter. Normal distributions for chapter 5. But those are all shapes that you could particularly have. What would it mean if the shape was uniform? What would it look like? Yeah. For the most part, it doesn't have to be perfect. It doesn't have to be perfect, but yeah, uniform would be like the same going all across. Like, for example, here's a uniform example where you'd be like, yeah, and then 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 yeah. Like, obviously, it's not perfect, but that's pretty uniform, or close enough. See, the thing is with statistics, as I've said time and time again, we use fluffy language. We can't use definitive language. And a direct consequence of that is that things are not going to be perfect. They're not going to be perfectly uniform or perfectly normal or perfectly symmetric or something along those lines. Instead, it's going to be like, yeah, it's close. And I can justify that. The last S is spread. How spread out your data actually is. Now, in regards to this, if data is symmetric, use standard deviation. If your data is symmetric, then use standard deviation. I'll give you a brief definition. I've talked about this a little bit, but I want to give you a brief definition of standard deviation when we get there. If the data is skewed, use IQR. I'll zoom in on that a little bit. People can see that a little bit better. Come on, paper. You may or may not have heard of IQR before. But IQR is what we call a measure of spread. And you can calculate it for the data that we have, but it's a very particular type of calculation. Now, I told you range. Range is dumb. Maximum minus minimum, dumb. Dumbest calculation. Doesn't tell you much. Oh, but this actually does. IQR stands for something called interquartile range. Interquartile range. So if you're hoping to describe data, if you're hoping to describe a distribution of quantitative data, which I'm going to get into those details in a little bit, you should cuss. You should absolutely cuss. Describe the center, describe any unusual features, describe the shape, and describe the spread of the data. And if you do that, you will have hit the qualifications for answering what the AP person wants of you. There's a few things that I need to deep dive into. First, let's talk about these two types of shapes. There's one shape there. And there's another shape there. These two distributions that I just drew for you are both skewed. This one is skewed right, and this one is skewed left. This is the proper terminology that I would prefer that you use. When I say skewed right, I mean that, yeah, most of the data seems concentrated right here, but there are a bit of data points farther down the line that are skewing my data to the right. It's like if, for example, in America, the average family income is somewhere between $40,000 and $80,000 a year. And $40,000 to $80,000 a year would be concentrated right here because a ton of Americans would earn somewhere in that range. But then there are people who are making like $300,000, $400,000, $500,000 a year, $1 million a year, but there are not as many people who do that. But they're on the farther end of that spectrum. As a result, if somebody's earning like, $10 million a year, $10 million is taking that average and it's pulling that average forward. It's pulling that average to the right. So you would say skewed right. The visual indication is where's the tail. If the tail is to the right, it's skewed right. If the tail is to the left, it's skewed left. Oh no, I almost fell and died. None of you cared. That's satisfying. Anyway, back to this. Let's talk about IQR. IQR, as I said, is something called interquartile range. It's something called interquartile range. How does one calculate IQR? Well, they calculate it in the following fashion. What the heck are those? Q3 minus Q1. What? Ugh. When I say the word quartile, what do you typically think of? What's the root word in quartile? Quarter. And how many quartiles do you think there are? Yeah, there's 4 quartiles. Q1, Q3. You already know Q2. Q2 was actually one that you've known for a long, long time. Q2 is your median. Q2 is your median. But they don't refer to it as Q2. They refer to it as your median. Q4 is your maximum data point. Each quartile represents a certain percentile, the 25th percentile, the 50th percentile, the 75th percentile. Your median is right in the middle. And if your median's right in the middle, then that is your 50th percentile. Q1 is the 25th percentile of the data, and Q3 is the 75th percentile of the data. Back in, I don't know when you first learned median. Was that middle school, 6th grade, maybe? I have no. I remember lessons a bit. Ridiculous. Anyway, when you were first taught about median, was it like one of those things where you'd line up all the data from lowest to highest, and then you gotta cut them out? Yeah, exactly. So you get to the middle. Cool. And then when you get to the middle, that's the median. If there's 2 data points, you average them together, and that's the median. Cool. Well, if you take the bottom half of that data from the minimum to the median and then do the same thing, you would eventually get Q1. And if you did the same thing from your median to your maximum, working your way in, you would get Q3. That's going to take forever. If you had like 50 data points, if only there was a way for the calculator to do it for you. If only there was a way for the calculator to do it for you. I'm dying. We'll get there. First, I got to define standard deviation. Standard deviation. Now, I may have verbally defined this for you, but I want to make sure that I actually get it concretely written down in your notes. A standard deviation is similar to the average deviation from the mean. Some data points deviate above the mean. Some data points deviate below the mean. Regardless of whether it's a positive or negative deviation, regardless of that, if you were to take the average absolute value deviation, you would get something very similar to standard deviation. Now, I say something similar because it's not exactly how you calculate it. What are you going to say? The mean absolute deviation? Maybe. We're not going to learn about that, though. Yeah. I say very similar because it's not exactly that calculation. I'm going to show you the formula. Now, I'm going to be very clear about this. The calculator can calculate standard deviation for you. That's not a problem. What is the problem is that you still have to know that formula, what I'm about to show you. You still have to know the formula for standard deviation because there are going to be various multiple choice questions which may test your knowledge in terms of the formula and where certain values are plugged in. And you need to be ready for that. So even though you are not going to be responsible for calculating standard deviation by hand, you still need to be familiar with the structure of the formula and why it does what it does. And I'm going to show that to you now. Woohoo! Come on, paper. Do your worst. Here's how you calculate standard deviation. Standard deviation is calculated in the following way. First, they do this fancy calculation. Have I told you about X bar? Have I? Yeah, I've defined X bar maybe, I hope, fingers crossed. I hope. We'll define it later. X bar is the average, it's the mean. If you do X minus X bar, you're finding the deviation. You're finding the deviation. Then, because some of those deviations are positive and some of those deviations are negative, they square them. They square them. Just like, okay, cool. But if you square a negative number, it becomes positive. You square a positive number, it stays positive. Cool, fantastic. So you have all these deviations. You have all these weird deviations. So what do? They add them all up. That's the symbol sigma, capital letter sigma. It's a Greek letter. It means the sum of. So you find all these individual deviations. You square them. You add them all up. Now, typically, when you find an average, you add everything up and then divide by how much there are. Well, here, you're not going to divide by how many data points you have. You're actually going to be dividing by one less than how many data points you have. It's very strange. And then, in order to undo the square, you square root that whole thing back. This is how you calculate standard deviation. It's very strange. It's very strange. Now, I'm going to show you something on the calculator. I'm going to show you how to calculate standard deviation by hand. But again, you're not going to have to actually do this yourself. You're not going to have to calculate it by hand, but that is the formula. I'm going to come back to that formula in a moment. But let's go up here real quick. I just want to show you something here. I have all my data points there, right? Now, I actually got to find the mean real quick. So let me actually do this, and then I'm going to show you how to do this very much easier. But I'm going to remember the number, 2.2825. That's my mean, 2.2825. So I would do something like this, L1 minus 2.2825. Notice where I'm typing this. It's just one of those fancy things here where if I do that, it actually fills in the deviations in the entire column. It's great. It's fantastic. But then I got to square that. So I'm actually going to do L1 minus 2. What was it again? 2825 or 2? I already forget. Hold on. Yay. Okay. I'm sorry. It's not that I didn't trust you. It's that I didn't trust you. Squared. So I'm going to square them all right there. You can see that. So it's like taking the deviations and then I square it. Chapow. So there they are right there. Some are bigger, some are small. But now I have to add them all up. I have to find the sum of that. So I actually have to find the sum of L2. There's the sum of L2 right there. I have to divide by how many data points there are. So I'm sorry, one less than that. So there's 16 data points. So I actually have to divide by 15. So there that is. And then I have to square root it back. So there's my standard deviation. So like, okay. But think of it in this fashion. Again, you're not going to have to know how to do that. You don't have to know how to do that. I'm showing it to you quickly because I know you don't have to know how to do that. But I wanted to show you this just to show you something here. So I got a value of 0.0638 as my standard deviation. What that really means is, on average, what were these? These were gasoline prices? Yeah, dollar. How much it costs per gallon. On average, the standard deviation 0.0638, that's really like 6.4 cents. 6.4 cents. So on average, the deviation from the mean is about 6.4 cents. Something along those lines. That would be kind of a verbal standard deviation. Oh man, it'd be great if the calculator could do all that for me. It can. Remember how I told you you're going to live in the stat button? Go to stat. Go to stat. And tab over to the right. Tab over to calc. You're going to live in this thing. Oh, get down there. Come on. Come on. There we go. The first one, 1var stat. Now, on your computers, when you hit 1var stat, it brings you to a screen where you tell it what list and stuff like that. Keep it on L1. As long as you have everything in L1, you're fine. If you put it in a different list, you would have to tell it a different list. But for now, just go down to the word paste. And if you go down to the word paste, does it say 1var stat on the home screen like mine? No? What does this say? Oh, not paste. I'm sorry. Calculate. I'm thinking of a different function. Yeah, just go down to calculate. There we go. That's what you need. I'm going to hit enter on mine as well. Now, I want you to notice a few things on this screen. First and foremost, you see X bar. X bar is your average. There's the 2.2825. It does it for you. Just fantastic. Hey, look. There it is. See you? I did it. I did it correctly. No one's impressed. Shut up. Anyway, no, minus 10. Minus 11, because you're wearing a Mets thing. Anyway. But this is the standard deviation. This is the calculated standard deviation for the sample. For the sample. We took a sample of 16 data points and calculated our standard deviation. We're going to write that information down in a little bit. This symbol may come in handy later, but we're not going to talk about that. Y'all see this arrow? What does that imply? There's more data. Also 16 data points. If you hit down, if you type or click down, look what you get. You get all those wonderful pieces of data. You get your Q3 and your Q1 and your median and all that stuff there. It does it for you. It does it for you. It's amazing. Hold on, let's write some stuff down. Zoom out. Okay. First, to get a 5-number summary. Sometimes they'll refer to it as a 5-number summary. Your 5-number summary is typically your minimum, Q1, median, Q3, maximum. That's your 5-number summary. To get your 5-number summary, after you've entered your data, of course, you hit stat, you tab over to the word calc, and you go into 1var stats, 1 variable statistics. That is what you need to choose. From there, again, just the idea, X bar is your sample mean, S is your sample standard deviation, and of course it gives all of that wonderful piece of information below it as well, the minimum, the Q1, the median, the Q3, and the maximum. It's all there. All of it is there. You need that information. You need to know what to do with that information. We can turn that information into graphical displays. And we talked about the histogram. Here's what I want to do. Let's change the histogram to a box and whisker plot. Let's change the histogram to a box and whisker plot. And I'm going to do that with you. I want you to do that along with me as well. See if you can kind of guess what I'm going to do next. So if I want to change that histogram to a box and whisker plot, I'm going to go back to stat plot. If you notice, it's set to histogram still. I'm going to hit enter. I'm going to go down to my fifth option, which is box and whisker plot. Then I am going to zoom 9 it. I'm not even going to look at the graph. I'm just going to zoom 9 it because I would like for the calculator to resize the window automatically for me. If I zoom 9 that thing, boom, box and whisker plot. They call it a box and whisker plot because literally there's a box with a couple of whiskers. I know, very creative. But look what happens when you hit trace. Look what happens when you hit trace, because this is how you create a box and whisker plot. When you hit trace, there's your median. And if you go to the left and to the right, there's your Q1, your minimum, your Q3, your maximum. It's all right there, all of it. Sometimes it would be in your best interest to do a box and whisker plot. Sometimes it would be in your best interest to do a histogram. Mr. Markey, how do we decide depending on the situation? Well, it depends on the context. It depends on what question they're being asked of you. It depends on a lot of different things. A lot of different things. That's what this thing is going to do. It's amazing what this thing does. Let me see here. Cool. Just one more couple of pieces of information at the bottom right here, and then I'll call it a day. Again, this is kind of a two-part lesson that I'm going through chapters 2 and 3 kind of at the same time. I'm going through chapters 2 and 3. Mainly, I focused a lot on chapter 3 today because I prefer to do that. Next time, I'm going to focus more of my attention on chapter 2. Your job, your quote-unquote homework, so to speak, is to make sure that you have read through chapters 2 and 3 to familiarize yourself with that information and to be ready to go, because next week, again, we're going to be deep diving this thing. Boom. Okay. The mean is affected by skewness. The mean is affected by skewness. The median is typically not. Now, what I mean by that is this. If I had a bunch of people, like when I was in high school, for example, I'm 5'6", and then I had a friend who was 5'7", and then we had a friend who was like 5'5". He was a shorty, and then we had a friend who was like 5'8" and stuff like that. Then another kid who was like 5'8" up here and stuff like that. Cool, fantastic. You could easily find like an average if you kind of had to estimate. Oh, the average is like, I don't know, like 5'6" and change or some junk like that. I don't know. It doesn't matter. You could find it in inches if you wanted to. But the median of this data, it looks like the median of this data is about what, 5'7"? The middle data point. It's not in order. I know it's not in order, but the median data point is 5'7". But then, and this is 100% true, 100% true. My best friend in high school was 6'8". Think about that for a second. Best friend in high school is 6'8". What does that do to the mean? What does that do to the average of our group of friends? Yeah, it jacks up the average. It jacks up the average. The average is probably over like 6 foot now, which does not represent our little group. But the median, the median did change a tiny bit. Maybe the median is now what? Can't even think right now. The median's like 5'7" and change or something like that. But it just changed a tiny bit. It's not typically affected. Anyway, we'll pick up with more of this next week. I'm going to sign off. Thank you all for joining me today. Pay attention to Google Classroom. Maybe I'll see you on Friday. Who knows? We'll be in touch. Bye-bye. Get out. Bye-bye.